Hi guys, we are going to take a look at this question where we have two cars, A and B, and they're moving at speeds of 15 meters per second and 30 meters per second in the same direction, and it looks like it's to the right. They are side by side when both drivers observe an obstruction ahead of them, as shown in the diagram. They apply their brakes and accelerate at minus 4.5 meters per second squared until both cars come to rest. That means that our final velocity is 0. Ignore the reaction time of the drivers. 4.1. Define the term acceleration in words. Please study the definitions. Acceleration is the rate of change of velocity. 4.2. Calculate the time it takes car A to come to a rest, and 4.2.2, the stopping distance of car A. Okay, so we have to calculate the time it comes to rest. So when it stops here, final velocity, right? So what do we have? We have the final velocity, which is 0. We have its acceleration, which is negative 4.5. We have the initial velocity at the top here, which is 15 meters per second. So we only need the time. So let's go look for a formula that gives me that where the time is the only unknown. So if you look at the first one, we have final velocity, we have initial velocity, we have acceleration, and the only unknown is time, and the question wants us to calculate time. So what do? We jot that formula down. Please jot the formula down, because you do get a mark for the formula. Okay, so they come to rest, so that means final velocity is 0. They start at 15 meters per second. The acceleration is minus 4.5, and the time is unknown. So you do your bit of math skills there. You 15 minus 4.5, you take the time over, you bring the 0 across, and you get 3.33 seconds. That is the time it takes A to come to a rest. And then 4.2.2, what is the stopping distance of car A? So now they want the distance. So what do we have now? We have final velocity, we have initial velocity, we have time, and we have acceleration. So what do we need? We need the distance. So you can use any formula that is comfortable. You can use this formula because it has everything we need and it has one unknown. We can also use this one because it has everything we need and one unknown. And we can also use this one, whichever is comfortable for you. Okay, so I think I'll just use the one that shows the x first, then you don't have to manipulate. So final velocity was 0, initial velocity at the top was 15 divided by 2, and the time we have just calculated is 3.33, and that gives us 24.98 meters. If you want to avoid using the time, because you might feel, oh, my time might have been incorrect, you could have used this formula, this third formula. You ignore the time there. Okay, 4.3. Which car, A or B, has the longer stopping distance? Support the answer with a calculation. So I'm going to do 4.3 on this blank page. Okay, so we have now calculated the stopping distance of car A, which is 24.98 meters. If you use another formula, you might get 25 meters, right? But they'll mark it correctly. So we've calculated the stopping distance of A. We have to now calculate the stopping distance of B. Okay, so we use a formula, whichever formula you want to use, where you have everything. So what do we have of car B? We have the final velocity of car B, which is 0, because they both come to rest. We have the initial velocity of car B, which is 30. We have the acceleration of car B, which is also minus 4.5. And that's all we have of car B. So we can't use a formula that has time. So we have to use this one, in my opinion. Or you can use a time formula and check whether the time is the same, whether the time is longer. I'll show you both. So in 4.3, we use the nice formula here, because I think because they ask you distance, you're immediately going to think of distance. That was 30 squared plus 2 minus 4.5. And you do your math calculations and you get distance to be 100 meters. So now you compare that to car B, which was 24.98 or 25 meters. And do you see? 100 meters is greater than 24.98. So that means car B has a larger stopping distance. Or you could have calculated the time, put an or you could have said something like final velocity equals to initial velocity plus time. That would be 0, 30 plus minus 4,5 times time, and you calculate time to be 6,67 seconds. Car A, it took car A 3,33 seconds to stop, and it takes it 6,67 to stop. So it takes car B longer to stop, so there's a larger stopping distance. All right, last question, 4.4. What conclusion can be made about the relationship between speed and stopping distance? The greater the speed, the larger the stopping distance. Okay, if acceleration is constant. So if we have constant acceleration, if speed is larger, the stopping distance will be larger. Okay, so they are directly proportional if acceleration is constant. Okay, and that's it, guys. See ya.